Okay, we have here today an interesting integral from the University Math Society. This was problem 277. We have the integral of x plus 1 over the square root of x squared plus x plus 1 dx. Okay, the first thing I notice is this here in the denominator. This is almost a perfect square, but not quite. So what I want to do with this is I'm going to just complete the square on this. We have a 1 coefficient on the x, so if I divide by 2, I can write this as x to the 1/2 squared. If you multiply this out, you have x squared plus x plus a fourth. We want a 1 there, so what I can do is add 3/4 on the end. Now we'll just go ahead and we'll rewrite the integral, so we'll have our x plus 1 still in the numerator, and then we'll use this over here, so we'll have x plus 1/2 squared. For 3/4, I want to write this as a perfect square, so I can write this as square root of 3 over 2 squared, and this is all inside the radical with a dx on the end. Now from here, what I'm going to do is a u substitution. This is kind of an optional step because it's not going to do much. It's just going to kind of clean it up. So you could kind of skip this substitution if you want to, but I'm going to do u equal to x plus 1/2, and then for our du value, we'll just have dx. And then I just want to get a value for x plus 1. So if I add a half on both sides of this equation, I can write this as, we can have equation u plus 1/2 equals x plus 1. So then we'll rewrite again using this in the numerator. So we're going to have u plus 1/2 here. Dx just becomes du. And then we'll rewrite the radical. This is going to become u squared plus square root of 3 over 2 squared. And now from here, we're set up pretty well for a trig substitution. One good way to do this is to substitute tangent for u. But instead of substituting for tangent, what I think I'm going to do is we're going to substitute with sinh of t. Now I want to have this value out front just to make this all work. So we're going to have square root of 3 over 2 here. I'll take a derivative. So our du is going to be square root of 3 over 2. Derivative of hyperbolic sine is just going to be hyperbolic cosine or cosh. So we're going to have cosh t here, dt. And now we'll just go ahead with this substitution here. So we're going to have our u value square root of 3 over 2 sinh t plus a half. Now our du value is going to be this, so this is going to be square root of 3 over 2 cosh t dt. And then for the denominator, when I rewrite this, our u squared, this is going to become square root of 3 over 2 squared, we'll have sinh squared, and then we'll have this square root of 3 over 2 squared. But then we have the square root of 3 over 2 squared in both these terms, so I can factor that out and take it outside of the radical as just square root of 3 over 2. This becomes a 1 over here. But then I can take this and cancel this with this 1 in the numerator. But then for this expression, we have an identity. I usually like to start from this kind of main identity, cosh squared minus sinh squared of x equals 1. And then if I just rearrange this, I can find this value. So I can rearrange this and get sinh squared of x plus 1 equals cosh squared of x. So when we apply this here on sinh squared t plus 1, this here is going to be just cosh squared of t. Okay, so now that we've cleaned it up and we've rewritten the denominator as cosh squared using this over here, but now this is inside the square root. So when I rewrite this again, we'll end up with just cosh t. Now technically I need absolute values on this, but because cosh is always positive, I can remove the absolute values on this. We don't need that there. And then I'll just bring down my numerator. But then cosh of t will cancel with cosh of t, and then we're just left with square root of 3 over 2 sinh plus 1/2. Now this is going to be easy to integrate because the integral of sinh is just cosh. So we'll go ahead and integrate. We're going to have square root of 3 over 2 cosh t. And this is just a half, so the integral of 1/2 is going to be 1/2 t. Now to finish this off, we just need to back substitute. I'm going to need a value for t, and I'm going to need a value for cosh t. Well, I can start with this equation right here that we have for u. First, if I multiply by 2 square root of 3 on both sides, I can write this as 2 over square root of 3 u equals sinh t. Then if I take the inverse on both sides just to isolate t, we end up with sinh inverse 2 square root of 3 times u. But we want to get this all the way back to x, and we have our u value, which is x plus 1/2. So for our t value, we can write this as sinh inverse distributing in 2 to this, we're going to have 2x plus 1 over square root of 3. So that's our t value. Now what about our cosh t value? What we can do is get that from our sinh value using this equation here. If we just take a square root on both sides here, then this is going to cancel here and we find that cosh is going to be the square root of sinh x plus 1. Now we have this expression for sinh t in terms of u. What I can do is get this in terms of x. So for sinh t, if I plug in our u value here, so this is going to be 2 over square root of 3, and then our u value is x plus 1/2. But then distributing in the 2, we see that this is going to be 2x plus 1 over square root of 3. So for cosh of t, we have this identity here so that we can say that cosh of t is going to be the same thing as the square root of sinh squared t plus 1. But we have our sinh of t right here in terms of x, 2x plus 1 over square root of 3. So for cosh t, I can write this as the square root of 2x plus 1 square root of 3 squared plus 1, but I'm going to write my 1 as 3 over 3. We'll see that that's going to help me simplify here in a second. So then squaring this out, this thing's going to become 4x squared plus 4x plus 1, and then the square root of 3 is going to become 3, and we'll have our 3 over 3 here. Well, now we have our common denominator, so putting these together, we end up with 4x squared plus 4x plus 4 over 3. But then here we have a 4 in common with everything in the numerator, so I'll factor out a 4 and take it outside of the square root. So this is going to give me 2 square root of x squared plus x plus 1, and I'll separate this 3 in the denominator and write this as square root of 3 here like this. And so now that's going to be my value for cosh of t. We'll write it over here, and we have our t value over here. I got rid of everything else because I was out of space. Okay, and finally we're ready to back substitute with this and finish this off. So we're going to have square root of 3 over 2 here. Our cosh t value is going to be 2 x squared plus x plus 1 over square root of 3. And then our t value is going to be just inverse sinh of this thing, 2x plus 1 square root of 3. But then we can do a little simplification because 2's cancel here, square root of 3 cancels here. And so for our final solution, we just have a square root of x squared plus x plus 1 plus 1/2 inverse sinh 2x plus 1 square root of 3 plus c, and that's it. Yeah, the pen's done. It's just done. Okay, so one quick note on this solution. If you did the trig substitution with tangent, that'll get you directly to the same solution, but with the sinh in terms of natural log. I did it both ways and I found it pretty similar, but this one gave me a more direct path to this particular answer. So there you have it, kind of a messy substitution. So we'll stop it there. Thanks everyone for watching. Have a good day.